Nearly 90% of enterprise AI projects never make it past the pilot phase. Despite billions invested, most organizations are getting AI wrong. In this episode, we uncover why enterprise AI is failing and what it really takes to make it work.
We are, I think it's safe to say, living in the age of AI. We see these demos for large language models, for generative AI, and they promise to completely revolutionize, well, everything.
Everything. And the enthusiasm is infectious, right?
Yeah.
The demos are just mind-blowing.
They are, but then you zoom out. You look at the actual balance sheets, and there's this huge, persistent gap between the promise and the P&L reality.
A chasm, really. And we're not talking about small misses. The research is pretty consistent on this. We're seeing numbers like 75%, even up to 95% of corporate AI projects failing
To deliver any tangible impact on the bottom line.
Exactly. No real P&L impact.
So that is the AI failure paradox we are diving into today. The algorithms are sound, the tech is getting better every single day, so why are these huge multi-million, sometimes billion-dollar projects just hitting a wall in production?
And that's our mission here, right? To show you that the problem isn't the code. It's almost never the code.
It's the organization, it's the strategy.
Precisely. And look, the failure rate is genuinely staggering. You've got major companies pouring money into cloud, into AI tools, but Gartner predicts that by the end of 2025.
So number?
30%. 30% of generative AI projects will be completely scrapped after the proof of concept phase.
So after they've already proven the tech basically works?
Yes. It confirms that the technical capacity is there. The failure happens when that shiny new tech meets the messy reality of how a business actually runs.
Okay, so let's get straight to the thesis for today.
Yeah.
It's a framework that structures this entire conversation. It's the 10-20-70 rule.
This is the essential lens for everything. BCG talks about this, and it just reframes the entire problem.
So break it down for us. What are the numbers?
Okay, so the rule suggests that only about 10% of the real business value in an AI project comes from the algorithm itself. The data science, the model training, all that is just 10%.
Just 10%. That's shocking to most people.
It is. Then another 20% comes from the tech stack, the plumbing, the data infrastructure, all of that.
Okay, so 10 plus 20, we're at 30% for all the tech stuff.
And here's the kicker. The monumental share, the other 70% of the value, comes entirely from developing new behaviors, new processes, new ways of working.
It's the people.
It's the people and the process. And if you only focus on that 30%, you are basically guaranteeing failure. You haven't prepared the organization to actually use the tool. That 70%, that's the real battlefield.
Let's get right onto that battlefield then with maybe the most famous cautionary tale of the last decade. IBM Watson Health. This was the failed prodigy. Just remind us of the sheer ambition here.
Oh, the ambition was total revolution. Nothing less than that. Watson was meant to be an AI doctor.
An AI doctor.
Yeah. It was designed to read, I think, 600,000 pieces of medical evidence, millions of pages from medical journals, patient histories, all to recommend tailored cancer treatments. The future of medicine was supposed to be Watson.
And IBM was all in. The investment was huge.
Absolutely. They saw this as the future of the entire company. We're talking about a reported $4 billion just on health data acquisitions.
$4 billion.
And then you had the big partnerships, like the one with the MD Anderson Cancer Center. That was a $62 million venture starting back in 2012, all to create this bedside diagnostic tool. They had the money, the data, the brand, everything.
And this is where the paradox just hits you in the face. All that capital, all that data, world-class talent. And by 2022, the assets are sold off.
Mm-hmm.
If the core oncology algorithm was sound, where did it all go so wrong?
It went wrong in that 70% column. The two core failures were completely organizational. First one was just inflated expectations.
They oversold it.
Massively. IBM sold this vision of its immediate capabilities that the technology, which was still pretty immature, just couldn't live up to. They went straight for these huge, complex problems like solving all of cancer treatment. They tried to run before they could walk.
And that gap between the demo and the reality, that just kills confidence.
It destroys it. And then came the second failure, which was, well, it was the messy real-world data problem.
Right. Data interoperability.
Exactly. That was the death blow. The system just could not handle the messiness of real clinical data. You know, doctor shorthand, different formats, simple human errors in the records.
Give us that one specific anecdote that really crystallizes this point.
The critical moment was in 2017. That $62 million MD Anderson contract expired after 4 years. And the reason it ended, it wasn't some bug in the algorithm.
What was it?
The hospital switched to a new electronic health record system, a new EHR, and Watson, it literally couldn't access the patient data anymore.
Wait, so the whole thing became obsolete overnight?
Instantly obsolete. The product was trained on the old system, and it couldn't talk to the new one.
A $62 million project died because it couldn't connect to a new database. That is the 70% problem in a nutshell, isn't it?
It is the perfect illustration. You can have the smartest model on Earth, but if it can't handle the real input stream, if it can't plug into the system where people actually do their jobs, it's useless. It's just a very expensive science project.
Okay, let's transition from high-stakes healthcare to, well, high-stakes real estate.
Yeah.
The spectacular $500 million miscalculation at Zillow offers.
A completely different industry, but a very similar story.
Zillow was the leader in data, right? Everyone knew the Zestimate, their price prediction model, and they used that confidence to jump into iBuying.
Instant buying, yeah. And then they had to shutter the whole business after losing just a staggering amount of money.
So what was the technical failure here? The Zestimate model was good, wasn't it?
It was good for its original purpose, which was driving traffic to their media properties. It was an engagement tool. But it was completely inadequate for a transactional business where you're putting real cash on the line.
So they were using an engagement model for risk management.
That's it, exactly. The model was largely regression-based. It relied on historical pricing data. And that's fine in a stable or a rising market.
But when the market turns...
When the market turns fast, that historical data becomes toxic. It's actively misleading. And that's where you get this technical flaw called concept drift.
Explain that for us.
Concept drift is when the fundamental relationship between your inputs and your output that changes. So for Zillow, the housing market cooled down very quickly in 2021. But the model, trained on old data, kept assuming the market was still hot.
So it just kept overpaying.
Consistently overpaying. Analysts estimated something like 2/3 of the homes they bought were underwater the moment they bought them. That led to a $500 million write-down.
And the CEO at the time publicly blamed the AI, right? He focused on that 10%, the algorithm's failure. But this connects back to the 70% rule. What were the strategic mistakes that made the AI error so much worse?
Oh, it was absolutely a management strategy failure. Zillow was pursuing hypergrowth at the expense of everything else, profitability, operational maturity, all of it.
How fast were they growing?
They acquired more homes in their last 2 quarters than in the previous 2 years combined. They were racing into this new business, iBuying, where they had no real operational experience, and they were just magnifying the errors of their immature pricing model.
So they took an estimation tool that was never built for that kind of risk, and then they just put the pedal to the metal with these hyper-aggressive growth targets.
Correct. So the failure wasn't just the AI. It was flawed strategy compounding a limited AI model and poor operational execution. They couldn't sell the houses they were buying. It was a massive, massive 70% organizational misstep.
So we've now seen 2 giants sink billions because they were focused on that 10% algorithm problem. Let's pivot. For you, the listener, how do you avoid this trap? If the algorithm is only 10%, where should you put the other 90% of your energy?
The answer is it's engineering and augmentation. Let's talk about the 20% first, the tech and infrastructure. You have to focus on disciplined engineering, not the glamour of the model itself.
So the plumbing.
The plumbing. Successful teams are obsessed with the last mile problem. That's the really hard part of integrating the model into your existing messy business systems, your CRM, your ERP, those ancient databases.
It's a huge mindset shift. It's less about training a smarter model and more about reliably connecting it to how the business already works.
That's it. And when you look at successful LLM deployments today, you know what the most critical skill set is. It's not AI research credentials. It's strong software engineering skills. You need people who build resilient systems, not just people who can train a model in a notebook.
Okay, so if the problem is integration, what specific architectural shifts are happening to make these systems more reliable and, maybe more importantly, more secure?
There are 2 big ones. First is building better guardrails in the infrastructure. The smartest teams are moving safety logic out of the prompt text.
Because you can always jailbreak a prompt.
You can always jailbreak a prompt. So they build the safety into the underlying infrastructure.
What's a practical example of a guardrail like that?
Something like session tainting. It's a security feature that labels data based on what the LLM is doing and who the user is. So if a user tries to trick an agent into grabbing, say, confidential client data from the CRM.
Which it shouldn't have access to.
Right. The system just refuses the action. The infrastructure, that 20% layer, knows the agent only has permission for public data. It's defense in depth.
That makes so much sense. And what's the second big architectural shift?
It's all about context engineering. Instead of just dumping everything into a huge context window and hoping for the best, the successful systems are focused on lean, highly relevant context retrieval.
Making the model smarter, not just bigger.
Smarter, not just faster and cheaper. It means filtering aggressively for relevance, using things like knowledge graphs, or even just letting the agent read from a file system on demand. Leaner context means lower cost, less latency, and way more reliability.
So these engineering steps cover the 20% infrastructure challenge. But that still leaves the big one, the 70%, the people and the process. Yeah. How do you drive that behavioral shift?
This is the crucial part. You have to frame it as augmentation, not automation.
The no man's land strategy.
That's it. You use AI to create a capability that was literally impossible for a human to do alone. If you do that, you get adoption instead of resistance. You're making your employee more powerful, not trying to make them obsolete.
Give us a great commercial example of that.
Look at Sephora. They didn't try to replace the beauty consultant. They used AI to let a customer virtually try on 200 shades of lipstick in 5 minutes.
Something a human could never do.
Never. And it led to a 4x increase in e-commerce revenue. The employees loved it because it made them better at their jobs. They could focus on personalized advice, not grabbing samples.
That's a perfect case of creating totally new value. How about in a more traditional enterprise setting?
First National Bank in South Africa. They have a really unique problem. 13 official languages. No single human banker can master all of them.
Right.
So they integrated AI for real-time translation. It gave their bankers a linguistic superpower, and that immediately opened up new customer markets they literally couldn't talk to before. The AI enhanced the banker's value.
So for the listener building their strategy right now, how do we boil this down? What are the success criteria?
I think it comes down to 3 questions you have to ask. 1, does this create a capability that genuinely did not exist before? 2, how does this make our people more valuable? And 3, are we creating new value or just redistributing existing value?
If you can answer all 3 of those positively, you're on the right track for that 70% challenge.
You're on the right path.
We've covered a ton of ground, but the core takeaway seems really clear. The gap between that slick AI demo and a reliable production system. It's not a technical gap. It's an organizational chasm.
And the secret isn't waiting for the next big model. It's applying rigorous engineering to that 20% and really thoughtful change management to the 70%.
And that leads us to a final, pretty provocative thought for you to consider. It's based on some really interesting data about where successful AI solutions actually come from.
Right. An MIT study from 2025 found this massive divergence. Externally procured AI solutions, so the ones you buy, they succeed at nearly twice the rate of systems built internally.
Twice the rate. That is a huge performance gap, especially with all the money going into internal AI labs.
It is. And it's because integrating this stuff successfully requires huge capital-intensive investment. You need specialized compute, the GPUs, and you need that specialized engineering talent to handle the 20% infrastructure problem.
And those come with huge sunk costs and, I imagine, very high risk.
Very high risk. So if we factor all that in, the talent, the GPUs, the integration challenges, the risk of building something that doesn't work, it raises a big question.
Which is, for most companies, is trying to build your own foundational models from scratch. Just a high-risk vanity project.
That is precisely the question the data is asking. You risk this scenario of profitless prosperity where you succeed in the lab, but the organizational cost of building and maintaining it internally just crushes your margins until success is impossible.
So the critical decision isn't just, can we build this model, but should we? Or are you better off buying a proven solution and focusing all your energy on that 70% problem, the integration and the people?
That's the multi-billion-dollar question.
We've given you the roadmap. Now the challenge is integrating that 70%, the behavior, the process, the strategy, into your next move.